Number 16. Colin is buying dirt to fill a garden bed that is a 9-foot by 16-foot rectangle. If he wants to fill it to a depth of 4 inches, how many cubic yards of dirt does he need? Okay, so that's our first question, and we will read the second question in a little bit. So first, we're going to talk about this garden. It's 9 feet by 16 feet, so we could say it kind of looks like this. It's longer this way, and so it says that he only wants to fill it to a depth of 4 inches. So we're going to be doing volume, so 9 feet by 16 feet, and he's only going to fill it up 4 inches. So let's figure out how much dirt this is, or how much volume. So notice right now I have a mix of units. I have feet and I have inches. I'm going to go ahead and convert the 4 inches to feet. You can convert the feet to inches if you want instead. It doesn't matter. Just choose whichever unit you want. So 4 inches is the same thing as 1/3 of a foot. Okay? So now let's go ahead and compute our volume. Volume for the prism would be area of the base times the height. The area of the base would be the 9 by 16, and then the height, he only wants to go up 4 inches, and we already said 4 inches is 1/3 of a foot. So these are his dimensions, length, width, and height. So when we multiply all that out, we get that is a volume of 48 cubic feet. Now notice in the problem it says, how many cubic yards of dirt does he need? So now they're wanting you to convert from cubic feet to cubic yard. So let's go ahead and talk about this. Let's take a look at how much a cubic yard is. So if I had a cube, okay, so we're going to pretend this is a perfect cube, and this measured 1 yard by 1 yard by 1 yard. Okay, the volume of this shape would be 1 cubic yard, right? So we'll write this, but we are in feet. So how many feet, how many cubic feet would be in this 1 cubic yard? That'll help me convert from cubic feet to cubic yard. So 1 yard would be 3 feet. 1 yard here is 3 feet, and 1 yard here. So now we're looking at a 3 foot by 3 foot by 3 foot cube. So this is the same as 27 cubic feet. So if you want to convert from cubic feet to yard, we're going to have to take this number and divide it by 27 cubic feet. So another way you can look at this, if you still don't understand why we have to do that, you can take a look at proportions. 1 cubic yard is the same thing as 27 cubic feet. So we're trying to find out how many cubic yards is the same as 48 cubic feet. Notice I have a proportion here. Okay, this is my ratio that we know, and then this is what we're trying to find, my unknown right here. So notice if we cross multiply, we're going to have to end up dividing 48 cubic feet by 27 cubic feet. So when you do that, you get that you have 1.78 cubic yards of dirt that you will need in order to fill this garden. So that is the answer to our first question. The second question says, if dirt costs $25 per cubic yard, how much will the project cost? So this is how many cubic yards we have. It's $25 for each cubic yard. So we would just multiply this by $25, and that will give us a total of $44.44 that we will spend in order to buy dirt to fill this garden. Number 17, a cylinder has a radius of 8 centimeters and a height of 3 centimeters. Find the height of another cylinder that has a radius of 4 centimeters and the same surface area as the first. Okay, so we need to figure out what the surface area of that first cylinder is. That first cylinder has a radius of 8 and a height of 3. So let's figure out his surface area. Let me go ahead and fix this right here. There we go. So surface area is 2 pi RH plus 2 pi r squared. We're given the radius and we're given the height, so we can go ahead and solve for this right now. So our height is 3, And we'll just plug all this in. I'm going to go ahead and leave everything in terms of pi just because things are easier. And this is a pi right here. So when we do this, we get 176 pi. So this is the surface area for that first cylinder. Then it says find the height of another cylinder that has a radius of 4. So let's go ahead and change this. Now we have a radius of 4, and we don't know what the height is. So I'm going to call that x. We're going to use the same surface area equation. This time we're going to plug in this number right here because that has the same surface area of the other one. So we're going to write 176 pi is equal to 2 pi r, and we do know the radius, which is 4, but we don't know our height. And then we're going to add 2 pi r squared. And hopefully this is barely going to fit on the screen. There we go. So now notice each of these terms has a pi, so I'm going to go ahead and divide that out so they will cancel. I'm left with 176 equals 2 times 4 times h plus 2 times 4 squared. So I'm going to rewrite this. Now I have 8 times h plus 32, because 4 squared is 16, and 16 times 2 is 32. I'm going to subtract 32 from 176, and that gives me 144 is equal to 8h. So when I divide by 8, I get that h is equal to 18. So the height of this second cylinder has to be 18 in order for him to have the same surface area as the first cylinder. Number 18, find the total surface area. So on this one, if you remember, like what we did on our project, the surface area is what's on the outside. Okay, we don't count anything that's on the inside. So we're going to go ahead and split this up into two polyhedron. We have our rectangular prism here down below, and then we have a triangular prism right up above. So you can see that right here, and then back here. So first, let's go ahead and do the surface area equation for the rectangular prism. Do notice that we are not going to do the bottom floor or this floor right here that's in between the two polyhedron because it's not on the surface, it's not on the outer part. Since this is a house, we don't count the floor, and then the inside floor, that's usually covered, you don't paint it, you put carpet or tile or whatever inside. So we're only going to take the lateral part. That's what's on the surface for the rectangular prism. So we're going to do the lateral of this, which is perimeter of the base times the height. The perimeter of the base, we have an 18 by 12 foot rectangle. So we're going to take 18 plus 12 plus 18 plus 12. So the perimeter here is 60. And now the height of my prism is from base to base. And since I made the ground the base, then the height is from here to here. So this height is 12 feet. Okay, so now here we can do 60 times 12. And that gives me 720. And this is feet squared. Now we're going to go ahead and find the surface area for this triangular prism. This triangular prism, we're painting all the sides and then the two bases, but we're not painting one of the sides here, one of the faces. So that would be this rectangle here. We will have to calculate total surface area and then subtract the area of this rectangle. Because remember, this rectangle right here is not the base. The base of this triangular prism is the triangle. Perimeter of the base times the height plus 2 times area of the base. So we're going to do that. Once we do that, don't forget we have to subtract the area of this rectangle right in here. So, in case you don't see that. Okay, so don't forget the perimeter of the base, that would be this triangle right here. So let's go ahead and erase this so we can see a little bit better. So my base is this triangle right here. So we know that the height from here to here is 12. This tells us that this whole length is 18. So from here to here would have to be 6. So the height of this triangle is 6. So since we know that, that'll help us. We have a right triangle right here, and this ends up being the leg, so we're going to put that as 6. And so we're trying to find the the hypotenuse, and that'll help us find the perimeter. So let me go ahead and draw that over here because it's a little bit messy right there. So remember, we have a right triangle right here. This is 6. Half of this length is half of this, which is 18. That would be 9. So once we find this, this will help us find the perimeter of the base, which is our triangle. So once again, we're not going to do Pythagorean theorem here because I know everybody knows how to do that. The hypotenuse ends up being about 10.8. So that's the same on the other side. So the perimeter would be 10.8 plus 10.8 plus 18. Okay, so that ends up being 30.6. Now the height of my prism is from base to base, from this triangle to the triangle in the back, and that's 12. Now we're going to add 2 times the area of the base. Now remember, the area of the base, that's my triangle shape. Let's clear this out a little bit here. We said that from here to here was 6, and then here to here is 9. So if you want to take a look here, the other half of the triangle goes this way. So the area of this triangle, right here, would be base times height divided by 2. The length of this whole base is 18, and the height is 6, and then we have to divide by 2. So remember, area of the base times height divided by 2, since it's our triangle. So now let's go ahead and compute all of this. In this part I get 367.2. Over here we have 18 times 6, which gives us 108. So these 2's cancel out, so that's why we didn't mention them. So then our total surface area here is 475.2. Now that would be the surface area if we had the whole triangular prism, but we don't. Remember, we have this rectangle that's inside of the house that we will not be counting. So we need to subtract the area of that rectangle. So we're going to do that in orange. I'm going to put here minus length times width. So this rectangle right in here that's inside the house, the length is 18 and the width is 12. So we have to do 18 times 12. So let's get our final surface area for the triangular prism. We have 475 minus 18 times 12 gives us 216, so we will subtract that. And this is 259.2. So now our final answer will be the sum of this surface area and this surface area. So together, I'll put here S sub t, this is my total. So I have 979.2. So this is our surface area, and this is feet squared. Okay, so last problem, number 19. The Transamerica Building in San Francisco is a pyramid 800 feet tall with a square base of 150 feet on each side. What is its volume? So let's go ahead and write the equation for volume of a pyramid. It's area of the base times the height divided by 3. Since it's a square pyramid, and they told us that the base is 150 feet on each side, then the area of the base will be 150 squared, right? Because it'll be length times width, so it's the same number twice. And it says that the height of that pyramid is 800 feet. So we're going to take that and divide by 3. We have everything we need. We just have to plug this into the calculator. So the volume of this Transamerica building is 6 million. So it's a very huge building. Okay, let's move on to part B. Part B says, if the Transamerica building has been built as a prism with the same square base, how tall would it have to be to have the same volume as the existing building? Alright, well remember, the volume of the building right now is 6 million. So let's just go ahead and write that. So we're trying to say, instead of a pyramid, what if it were a prism? What would the height have to be to have the same volume? So the equation for the volume of a prism is area of the base times the height. And we don't have to divide by 3 because that's only for a pyramid. So we can go ahead and plug in the volume. We know that that's 6 million. And then the area of the base is the same. Okay? So that's not changing. So area of the base is length times width, so it's 150 times 150. We're trying to figure out what would the height have to be of this prism in order for him to have the same volume. So the only thing we have to do here is divide our volume by 150 squared. So we get that the height would have to be 266, whoops, 0.6 repeating, so in 2/3, so 0.67 feet. So that's a big difference from what we had before. Okay, so always use the information you're given, plug in what you know, and then solve for your variable. Make sure you guys study.